Module on linear trend forecasting prepared by Professor Amit Datta, School of Business, George Mason University. Sometimes the data based on which you're doing the forecasting exhibits a linear trend, either increasing or decreasing, surrounded by some random fluctuations, as you see in the chart over here. So in column B, you have sales data for 10 years, and when one plots that data, as you can see on the figure on the right hand side, that the pattern clearly exhibits a linear upward trend. It could also have been a negative downward trend, but in this case it shows a linear upward trend surrounded by some random fluctuations. So what if one wants to do forecasting of the linear trend in this circumstance? Um, a very common technique that's used for this purpose is simple linear regression, where the dependent variable is the time series quantity, in this case sales, and the independent variable is the time scale, in this case in years. So let's see how one would go about using regression for that purpose. So let me move the file, the chart down a little bit. So I go to data, data analysis, regression. The dependent variable is the sales data itself, of course, in column B. And the independent variable is time, in this case in years. And labels are checked off because we have labels in the first row, and our output range will be put in cell E2. So there we have the output. Okay, so you can see from this output that the regression equation, in other words, the linear trend equation, we can write very easily as this is your regression equation. It would be sales is equal to 20.4 plus 1.1 times here. Okay, and you can see where those two coefficients come from. Here is your intercept 20.4, and here is your slope 1.1. So if you wanted to predict the linear trend for year 11, so the sales value for year 11, your prediction would be sales is equal to 20.4 plus 1.1 star, or multiplied by 11, whatever that comes to. All right. So that's the linear trend. And by the way, you would certainly look at the diagnostics of the regression. So I look at the p-value for the slope over here is 0.0009. It's highly significant even at the 1% level, which tells me it's highly unlikely that the true slope of the trend is 0. So I'm pretty confident that the slope I got is non-zero. And if I look at the 95% confidence interval over here, you see that we are 95% confident that the true trend lies between 0.6 and 1.59. In other words, that range does not include 0. So I'm very, very confident that we have a trend here. And the estimated value here, the point estimate is 1.1, and that's the one that's the value we would use. Moreover, the R squared value that you see over here, 0.76, is also pretty good. So all in all, when you look at the significance of the slope in the R squared, one would conclude that in this particular situation, the fit of the linear trend line is actually quite good. Now, it's important to note that the linear trend line that we have fitted is based on our assumption that the linear approximation of the trend is a valid one. And in this case, I've just eyeballed the scattergram and come to the conclusion that a linear approximation is well suited here. Now, if your eyes tell you that the scattergram does not exhibit a linear trend but something nonlinear, then of course it would be a stretch to force fit a linear trend equation onto this pattern, uh, and one would have to look for other trend shapes. But a linear trend is a very common pattern that exists in time series data. So there are many situations where one would want to fit a linear trend onto a time series. Now, you've seen how to do that using linear regression. Now, just as an aside, something else that's done in in the course of forecasting is once you do have this linear trend equation, what's often done sometimes is to take this trend equation and do what is known as detrending the data. So you remove the trend from the data. So you take the raw sales data that you have, and using the equation that has been determined from the regression, you subtract out the trend, and what you're left with is a random fluctuation. And then one can use a moving average or time series kind of analysis to do a prediction of the random variations that you see around the trend line. And once you have those two pieces of the forecast, then you can splice a forecast back together by forecasting the random variations using a moving average or time or exponential smoothing, and take the trend from the linear regression, splice those two things back together again. So overall, this is how linear regression can be used to determine linear trend patterns that might exist in time series data.